Problem 2 of the BC 2017 exam, and basically you have two polar curves that are given from 0 to pi over 2, and there's a region R bounded only by one of them, and the region R is bounded only by F, and then you have a region S that's bounded by F and another polar curve G, right? And here's the region S. And then we're asked a bunch of questions about this. All right, so for it to be specific. So the first question is here in part A, and it's to find the area of R. Now, we know that the area bounded by some polar curve R is equal to 1/2 of the integral of R squared d theta, and the integral goes from, like, whatever the bounds for our polar curve are, which in this case is along theta, that is from 0 to pi over 2. But I thought that was pretty clear, that I didn't need to say along theta because of that d theta there, right? So we changed theta, like, from 0 to pi over 2, or more or less, however much you want. Those are the bounds. But yeah. Okay, cool. So this I do on my TI-89 calculator. And so if you do the same, it'll look like this. So yeah, the correct answer is right here. Right here. I have a bunch of videos teaching you TI-89 calculator skills, so check them out. But yeah, there it is. Yeah? Okay, cool. All right, so ready to move on to part B then. So let's go to part B. All right. Part B says, let's see, what does it say? I believe that is this guy here. Yes. Part B says, and this is pretty straightforward question, but yeah. Part B says, let the rate theta equals k for some constant between 0 and pi over 2 divide S into a region of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. You read it. Why am I even reading it with you? The point is that we have some ray theta equals k, right? So remember, we start from the positive x-axis and then we rotate, and that's how we get theta, right? Like different values of theta, we rotate. Okay, cool. So it's saying that, like, as we do that, there is some theta value that divides the region into two parts. Because, like, the region, like, over here is bigger, kind of, like, wider than the regions here. I'd imagine that the value of theta would be less than pi over 4, which would divide the first quadrant into two equal parts, right? So it'd be something like this. It'd be the correct visual is what I'm saying. But yeah, this is the value of theta we're trying to look for, that value of theta made with the positive x-axis. Okay, and so we call this k, right? We call this value k, and I guess I can keep this right here, but yeah, there it is. Okay, so for theta equals k, we're asking, will this equal, will that equal this stuff? And yeah, so if we set up the right equation, it will. And here are a couple of ways to do this. I've been, like, slow to get to this, so let me start. So one of them is to say, hey, like, since this is theta equals k, we can say the integral from 0 to k of 1/2 of, and it's the region S, so 1/2 of, and it would be g squared, and it's g of theta, but I'll just say g squared, minus f squared, and then d theta, right? So right now what I wrote is an expression for this area here, and we need that to equal this here. Well, that's, we need it to equal, well, I still need a 1/2. 1/2 of the integral from k, this time we start from k, and then go to pi over 2, right? To cover what I just did. So k to pi over 2, and then it's still g squared minus f squared d theta. Now, you could see that 1/2 is on both sides, so it's unnecessary. So, like, feel free to get rid of this 1/2 here and to get rid of this 1/2 here. But here is one such equation that would get us the value of k that we're after. Another equation that would do the same is the following, and it's like you get it. We didn't need to say this, but it's that 1/2 of the integral from 0 to k of g squared minus f squared d theta, right? This again equals that. We can say that this is going to be half of, so 1/2 of 1/2 the integral from 0 to pi over 2 of g squared minus f squared d theta. And you're like, duh, because all I said this time is that this here, which I've represented by this, is equal to half of the area of the whole region S. And this is the area of the whole region S, and I've written a half in front of it, right? Okay, and of course, again, you see you can cancel this 1/2 and that 1/2, and what you have to write is what's left. But yeah, either of the two equations will do the job, yeah? Okay, cool. Now, we move on to the next part then, right? Okay, I might want to first, yeah, okay, that's better. So the next part, and I want to delete more stuff. The next part will say the following, which is, let's see. So the next part is what? Part C? So let's see. It'll say this, and that is, for each theta, 0 to pi over 2, for each theta, let W of theta be the distance between points with polar coordinates f of theta, comma, theta, and g of theta, comma, theta. Hey, here, I've drawn one such W of theta. W of theta is represented by that segment. That's one of them, right? And of course, I could have done it over here, and W of theta would, in blue, be now this, right? Because it's saying, you fix a theta, and then that's this theta and this theta is the same. And then if you're calculating the distance on the two curves, then it's just the difference of G and F. Remember, G is the outer curve, and F is the smaller inner curve, right? So, okay. So you'll do the difference between G minus F, and that's going to be what W of theta is, right? Okay, so W of theta, right? So we see that W of theta, let's first write this, is equal to G of theta minus F of theta. Now what? So it's saying, call this thing W of theta, this difference, and then it says, write an expression for W of theta. I just did. And then it says, find W sub A, the average value of W of theta over the interval. Okay. Now, we think back to what we know, and what we know is that if you have a function f, then, or let me use h since we use f here, I don't want it to be confusing, but yeah, let's suppose that you have some function h, then the average value of h on an interval ab, we know, is supposed to equal, let's say it's h of x, is supposed to equal 1 divided by b minus a times the integral from a to b of h of x dx, right? So then that, in this case, is going to say, for that, which is the average value of W of A, so W of theta, rather, sorry, the average value of W of theta, which we can very cumbersomely write W of theta sub A, or, as they have done, we could just abbreviate with W sub A, this is going to equal 1 divided by pi over 2 minus 0. And this is the 1 over b minus a part. Notice that this is just 1 divided by pi over 2, which is the same as 2 over pi, right? 1 over pi over 2 is the same as 2 over pi. So we have that. And then times what? The integral from 0 to pi over 2. So the integral from a to b of the function that we're averaging, which in this case is w of theta, which by definition is equal to g of theta minus f of theta, and then d theta, right? Okay. All right, cool. So, the rest of this I do on the TI-89 calculator, and let's see, what do I have to offer you there? This is part C, right? That's that. Okay, what I did is, yeah, I typed f under y1, and then I typed g under y2, and then I did y2 of x minus y2 of y2 of x minus y1 of x. Oh, hold on. I didn't mean to adjust it that way. Let me just get this right, and then so I did y2 of x minus y1 of x, and that's w of x. So I used x instead of theta, but so be it. But otherwise, I did the integral from 0 to pi over 2, and then multiplied by the appropriate constant, 2 over pi. And yeah, as I've said many times already, I have videos that teach you about the TI-89, so watch those to figure out, how to type this. But yeah, and obviously y2 is, if I haven't already said, y2 is g and y1 is f, right? And I typed them under y equals, and yeah, okay, cool. So the answer is right there. Yeah, okay, cool. So let's move on to the final part. The final part is part D, and what does part D say? I don't know. Let's see. Using the information from part C, find the value of theta for which w of theta, which recall is equal to g of theta minus f of theta. So we're asked to find the value of theta for which this is equal to w sub a. Remember, w sub a is an abbreviation for w of theta sub a, which is the average value of w of theta, which we calculated on the last part to be 0.485, right? So we need to find theta so that this is equal to that. And if you do it correctly, you'll find that theta, and you can do that on the TI-89 using equation solving methods, and I have videos on that if you need to see how to use your TI-89 to solve equations, in particular trig equations. But yeah, I have theta equals, and it's a radian value, equal to 0.517. Okay, or 518 to 3 decimal places. You can use either 0.517 or 0.518. Doesn't matter. Anyway, that's the theta value, okay? So this is the theta value where w of theta is equal to w sub a, okay? And then now what? It's asking, is the function w of theta, so is this function, the difference between g and f, increasing or decreasing at this theta value? Give a reason for your answer. Well, clearly, our answer is going to depend on the value of w prime of 0.517, right? And again, we have to be in radian mode because this is a radian value of theta. But yeah, since we're trying to figure out if w of theta is increasing or decreasing, we should look at the derivative, right? In particular, we should look at the derivative for this theta value, and if the derivative is positive for this theta value, we know that w of theta is increasing at this theta value, and if it's negative, we say that it's decreasing at this theta value. And so here's how I did that. So I went to my TI-89 and I typed under y1 f of theta, and then, well, I typed it as f of x, and then under y2 I typed g of theta, And so I typed g of x, and then I did y2 minus y1 right here, y2 of x minus y1 of x, and that means I have w of x, or in other words, w of theta. And then this ddx means take the derivative of it. So I took the derivative of w of theta, or w of x, for the calculator purposes. And then I got this long derivative, so long that you can't even see it. You got to scroll some more to see it. And then what did I do? Well, I copied and pasted this derivative that I have circled here under y3. I went to y equals, and I pasted it under y3. And then from that same old trick that I've already taught you in previous videos, I went to my home screen and I asked for y3 of the particular theta value we wanted, 0.517, and it told me that it's negative. That means that w prime is negative for this theta value, and by the way, that was this negative value, but all I care is that it's negative, not about the value. So since this is true, since w prime of theta is less than 0 for this theta, we see that w of theta is decreasing at this value of theta. Yeah? Okay, cool. So you might want to do a little bit more writing, because I said it to you, talking. But yeah, so you get full credit for your test. But yeah, that's it. Okay, cool. I hope you enjoyed this and that you found it helpful. Keep watching.